Hi guys, so we're going to start looking now at 5.3 SAS, Triangle Congruence Theorem. So SAS stands for side, angle, side. So we've done SSS, which is side, side, side. Now we're going to do side, angle, side. So the idea is that with these theorems, you don't need to know that all three sets of sides or all three sets of angle pairs are congruent. You just need certain information that would then allow you to say, okay, these are congruent. So if we know that we have two sides and their included angle, I'll explain that in a second, are congruent to the two sides and the included angle of another triangle, then we can say the triangles are congruent. So if we know those three bits of information, then we can say that all six pairs are congruent. So this included angle idea, think of what included means. It means something that is part of. So if I look at this angle here, I have side AB pen's acting up again, hang on. And then I have side BC. The angle that they form, so this angle here that would be formed by those two sides would be called my included angle. So again, think of it as being like part of. It's part of those two sides. It's made by those two sides. So officially the angle made by two line segments with a common vertex. And for line segment, that could be a ray or a line as well. So we're going to determine if each triangle pair is congruent by side, angle, side. We're only going to focus on that one for now. If they are, we'll list the two sets of congruent sides and the one set of congruent included angles. If not, we'll explain. And then we'll be writing the triangle congruence statement as well. So getting my highlighter here, I have that this side with two tick marks is congruent to this side with two tick marks. And then this side with three tick marks will be congruent to this side with three tick marks. So I have the two sides. Now I want to look at the included angle. So if I look at triangle ABC, my included angle would be this angle that's formed by the side AC and side BC, the blue and the pink. Now the question is it going to be congruent to this angle? If it is, then I can say that I have side, angle, side, because then I have the included angles. So we do have to think back to some prior knowledge. I know that these two angles are actually vertical angles, and vertical angles are congruent. So vertical angles. So now again, if I look at my triangles, I've got side, angle, side, congruent to side, angle, side. And again, the idea of the included angle is that it's the angle formed by the two sides we're focusing on. So if I write this out now, I know that side AC is congruent to DC, the blue. Then I have my pink sides. BC with two tick marks is congruent to EC. In case you're unsure too, this point right here, this point right here is C. Having a hard time with this dang pen. Okay, come on, pen. Oh, doesn't want to work at all. There we go. Okay. And then I would say that angle, now be careful here because I cannot say angle C because what I have are adjacent angles. So remember, when you have adjacent angles, you actually have to use three letters. So if I want to talk about this angle, I would have to say angle ACB is congruent to So if I want this angle here, again, I would need three letters. That would be formed by DCE, or you could say ECD. Remember, angles can be named with three letters. It doesn't matter the order as long as that vertex is that middle letter. So C would have to be in the middle, just for some good review. All right, so what I can see now is by side, angle, side. So I have set of sides, second set of sides, and then my set of congruent angles that are included. I can say by side, angle, side that these triangles are congruent. So triangle, remember the order matters here. So if I'm going to say ABC, so A to B to C, I've got to follow that same direction when I name the second triangle. Good review from the side lesson. So I started on my blue side on my first triangle, so I need to start on the blue side of my second triangle. And I went towards the pink, actually, along the unhighlighted side. So I'm going to start at D to E, and then along the pink to C. Okay, again, that's because the order matters on how you name a triangle. All right, let's look at number 2. So I have side AC is given as congruent to side BD based on those tick marks. And then I have this later in the notes just to make sure we review the definition, but we have this idea with side that like any side would be congruent to itself. So I can actually mark that overlapping side as congruent to itself. Now, in order for me to use side, angle, side, I've got the two sets of congruent sides. I've got AC is congruent to, let me write this out, DB. And I've got that BC would be congruent to itself. Again, we'll come back to that idea. The third piece, this A here would be, remember, it's called the included angle. So I would need the angle that is formed by these two sides, which means I need this angle. And I would need to know that this angle here is congruent to the one formed by these two sides. So this is marked with one arc, meaning it's actually congruent to this angle. So what I notice is, although I have an included angle congruent to an angle from the second triangle, it is not congruent to this included angle, which means I cannot use side, angle, side. So since angle ACB is not congruent, to angle DBC, the triangles are not congruent. I'm going to have to write shorter here. Triangles aren't congruent by SAS. And I ran out of room, so I'm using my symbols. Okay. Okay, so in number 1, I had two sets of sides that were congruent and the included angle, meaning the angle formed by those two included sides. But on number 2, although I had the two sets of sides, I was missing this angle. It was not the included angle for triangle ABC that was congruent, so I cannot use side, angle, side. Alright, so same idea here, same directions, but now we're going to look at where we have numerical values. So I have 46 and 46, those would be congruent. 74 and 74, so I've got my two sets of congruent sides. So LJ, my purple, would be congruent to PM, and I've got that JK, is congruent to the other pink, and I lost it. Okay, MN. So now what I need to check is, are the included angles congruent? So here I've got 37 degrees at my included angle. So I look at my included angle in the second triangle, and I do have that it is 37 degrees. So that tells me that angle J is congruent to angle M. And here I don't have adjacent angles. That's why I was able to just use one letter to name the angle. Okay, so since these three bits of information are true, I can say by side angle side triangle. Now here's where the order matters. Get this relabeled here. There we go. A little different. Alright, so I'm going to go in alphabetical order. So I'm going to go J, K, L for naming my triangle. Would be congruent to triangle. So I started pink here, where the pink and purple intersected or met. I should say met. And then I went along the pink, along the unhighlighted side, back to J, along the purple. So I'm going to do the same movement here. So I would go M to N, along the non-highlighted side, back along the purple. So that would mean I would go M, N, P. Got it. Alright, next one. Got 30 and 30. 40 and 40. So the sides meet the requirements so far. So for side angle side, got the sides. Let's check on that angle. So this here would be my included angle. That's hard to see. It is marked as 90 degrees with that little box. And if I look at my included angle over here, I actually have 95 degrees, which means these included angles are not congruent. So since angle E is not congruent to angle H, these triangles are not congruent. Alright, number 5. So here's that reflexive property again. I just wanted to review that term. It says that any side is congruent to itself. Oops. I don't know what I did. Okay, so reflexive property. So that means that BC would be congruent to BC here. So if you're looking at triangles that actually share a side, you can say, so although I'm not given that this second set of sides are congruent, you can say that they are by the reflexive property. Okay. So if I'm doing side angle side here, I've got my two sets of sides. Now I need to check that included angle. So I've got one arc on this angle here at angle ABC. And then on my second triangle, here's my included angle. It's got one arc as well, which means they are congruent. So AB purple is given as congruent to DB. Then our orange side, BC, would be congruent to itself. That's where we use that reflexive property that I have here. And then we know that angle ABC, okay, we have to use 3 letters because we have adjacent angles, be congruent to angle DBC. So by side angle side, the triangles are congruent. So as far as naming goes, I'm going to start at A and go to B, and then to C. So I went along the purple and then along the orange. So I'm going to have to do the same here. So I'm going to start at D, go along the purple to B, and then along the orange to C. Oops, forgot my triangle symbol. D, B, C. And that's it. Alright, next one. So I see that PS is congruent to QR because they are both 2 inches. And then I would have PR, this overlapping side that the triangles share. Not overlapping. The side the triangles share will be congruent to itself by that reflexive property. So let's check now the included angle. So the included angle would be the angle formed by these two sides I have highlighted. So that is this one. The included side of the second triangle, included angle, would be this angle here, since it's formed by those two highlighted sides. And they are marked congruent. So we've got PS is congruent to RQ. PR is congruent to itself by the reflexive property. And I've got that angle. Got to use 3 letters because we've got adjacent angles again. SPR congruent to angle QRP. So by side angle side triangle. So I'm going to start at S, go along the purple and then along the pink. So that would be SPR. So same direction over here. I'm going to go start at Q along the purple, then along the pink. So that would be QRP. Alright, last one. This one says my directions are cut off. But it says to determine the value of x that would make these two triangles congruent by side angle side. So I do have this first set of sides. I've got that AC is congruent to DF. They're both 9 inches. And then what I want to do is find x so that this side here is congruent to this side. That would be our second set of sides. So what I want is for BC to be congruent to EF. That would then make these triangles have the 2 sets of sides. Now if I look at the included angles, they are both given as 30 degrees. So I do know that angle C is congruent to angle F. Only have to use 1 letter to name those angles because there were non-adjacent angles there. So if I want these 2 sides to be congruent, that would mean that 2x would have to equal x plus 4. So I'd subtract x on both sides. And we get x equals 4. And you could check your work here. 2 times 4 is 8, and then 4 plus 4 is 8, and 8 is equal to 8. Alright, that's it. As always, pause if you have questions. Let me know where you paused. Reach out if you need more help. I'm here to help you guys during this time. Okay? I miss you all. Bye.